Rob Richardson, who will be speaking about service mesh to service mesh. Over to you, Rob.
Marvelous. Welcome, everyone. So glad to be here in New Zealand. I'm excited we get to talk about service mesh to service mesh. I'm a software developer, and I do a lot with Kubernetes. You can find this content online right now at robrich.org. If you come to robrich.org and you click on presentations here at the top, here is today's talk, service mesh to service mesh, and you can grab the slides online right now. So let's dig in. Do you remember when you first learned to drive, or when you first learned to, that you could leave town and see other towns? You know how freeing that is, how engaging, how exciting it is to be able to expand your horizons? It's really fun driving on an empty road like this, where we have not a lot of traffic and where we can move as fast as we need to. Let's imagine a country road where it is just that empty. Well, in time, the country starts to build up and it becomes much more urban, and eventually we get to, well, traffic jams like this. Our traffic really isn't moving very efficiently anymore. And so, well, how do we solve this? We'll make similar analogies as we start talking about service mesh, but how are we going to solve this traffic here in our rural town that now has gotten, well, congested? Well, let's start by putting a police officer at the edge of town. The police officer can check to see if anyone's going too fast and stop them so that we make sure that we're going the right speed limit. Now, on the upside, we've maybe solved our traffic problem. We don't have as much congestion. Everyone's kind of flowing at the same rate now. But we've not optimized for optimal journey time. We've optimized for conformity. All of us are, well, going as slow as the slowest person. What we really want to do is we want to optimize like this. We want to have a mechanism where the cars can communicate together, where we can prioritize traffic, and traffic that needs to go really fast can efficiently. And traffic that may have less priority can meander if they want to. If we have a mechanism like this, we'll probably reach our journey faster than when we just put the traffic cop at the edge of town and slowed everybody down. This optimizes for delivery, not optimizes for conformity. As we get into service mesh, we'll see really similar analogies where we have mechanisms, we have traffic, we have network traffic flowing through our cluster. And in most cases, the traffic flows unabated. It can flow wherever it needs to. As we look at service meshes, we'll look at namespaces inside Kubernetes. Namespaces are good organizational tools, but they are not security boundaries. Well, what is a service mesh? In this talk, we'll take a look at both Istio and LinkerD. We'll see demos of both, and we'll see when should I and when should I not use a service mesh. First up, what is a service mesh? A service mesh will manage traffic between services in a graceful and scalable way. Now, the cool part about a service mesh is it really answers that fundamental question: how do I observe, control, or secure communication between microservices? If you need to observe, control, or secure communication between microservices, that's when you should reach for a service mesh. If you don't have the need to observe, control, or secure communication, then you may not need a service mesh. A service mesh will observe, control, or secure. Observe. A service mesh will stand in between all of the traffic flowing through my cluster. Because it's standing in between, it can observe the traffic flowing through. Is this a normal pattern? Is this irregular? Am I getting too many errors from my service? I can watch that traffic and see who's calling who. In time, I can control it. Let's create policies and identify when should we be able to communicate with that other service. And is this service communicating in ways that we didn't expect? Is there a new rogue service that we didn't expect that we should really lock down? Observe, control, and secure. We can do mutual TLS between our microservices. And the benefit of putting this inside of a service mesh is that our applications don't need to change. Our applications can continue to build the content the way it always did, but as the communication goes between pods in our Kubernetes cluster, it is running through mutual TLS, together with a trust chain ensured by the service mesh. Observe, control, and secure. Now the cool part is when we moved from a monolithic to a microservice architecture, we started to need these kinds of concerns. Let's look at what problems a service mesh solves. In a monolithic environment, we had all of our content enclosed in one executable. We would deploy that executable, maybe infrequently, and we would keep that executable up to date. Well, the beauty there is our private methods were private. We would do memory calls to get at our private mechanisms. When we moved to microservices, we could deploy a whole lot easier. We could scale a lot easier. There are lots of benefits to microservices. But our internal services now have an IP address. And so now we need to secure the communication to those microservices. By default in Kubernetes, all traffic can communicate with all other traffic. Namespaces are organizational boundaries. They don't block traffic going between namespaces. Any container can communicate with any other container. Now, as we talk about traffic within our cluster, let's define a term, NorthSouth and EastWest. When we talk about north-south traffic, this is traffic flowing into our cluster or traffic flowing out of our cluster. When we talk about east-west traffic, this is traffic flowing between microservices within our cluster. Now, the beauty of a service mesh is that it can handle both north-south traffic into and out of our cluster and east-west traffic, traffic between our microservices. Well, as we started upgrading from monoliths to microservices, we started putting in API gateways. Here's this fence in front of our service. Now, this API gateway fence is interesting, but it's only a fence. It's the traffic cop at the edge of town. Now, it can do a really good job at ensuring that people don't come in too fast into town, that everyone is behaving as they expect as they enter town. But once they're inside town, now we've got services calling other microservices. Now, that's probably okay. But our microservices are calling into each other's data stores too. Our API gateway can't do anything about this. Our API gateway is just a fence around our cluster. The API gateway is really good at monetization and metrics, throttling, monetizing our application. So API gateways definitely still have a place in our modern infrastructure. But our API gateways can do nothing about this microservice calling into this other data store. We have no observe, control, and secure besides the boundary to our application. That's what an API gateway is. And thus, a service mesh. How does a service mesh work? Here's the fundamental principles of how a service mesh is able to communicate. Let's say we have a service A in our cluster, and this service A is inside this pod, and it needs to communicate out to service B here in this other pod. Now, these are two containers, service A and service B. Without a service mesh, service A would just reach out to service B, make a web request, and send off the content. With a service mesh, there's a little bit more involved. Service A will reach out to service A's proxy. Now, the service mesh will install this proxy as a sidecar container inside the same pod. And so this is still a network boundary, this pod boundary. Service A reaches out to the proxy. The proxy goes and checks in with the control plane. Is service A allowed to communicate with service B? In this case, the control plane is going to say yes. And so service A's proxy reaches out to service B's proxy. Service B's proxy is going to do the same check. Hey, control plane, am I able to communicate from service A? And in this case, the control plane will say yes. Service B proxy will forward the request on to service B, and then service B will reply. It will come through this tunnel back to service A. This is the fundamental principle of how a service mesh works. We put these sidecar containers into each pod, and these sidecar containers can go check in with the service mesh to do all the things. Now we can put a sidecar proxy here in our ingress controller so that data flowing into our cluster will also be able to check in with the control plane. And we can also put a proxy on the way out of our cluster for egress, so that outbound traffic can check in with the control plane to make sure that that's allowed as well. Wherever we need to create control points, connections in our cluster, we can put these sidecar proxies in place, distributed by the control plane. Now the control plane then becomes the brains here. All the traffic checks in with the control plane, and the control plane can do things like, well, observe, secure, and control that traffic. Observe, control, and secure. Because we have a sidecar proxy between each connection, we can see the traffic that flows through it. Now maybe we're just checking status codes, we're not, inspecting packets, but we can see when services start to misbehave, we can see when services are going down, we can see when connections are made, what connects to what. Because we can visualize and observe that traffic flowing between all the services, we can start to construct policies. Let's create access policies. I'm not going to let this service connect to that service anymore. Now we do need to work with our developers to ensure the application doesn't go down, but we can work with those developers to ensure that the applications behave as we expect. And what's particularly cool, we can create those connections over mutual TLS if we opt into it. We'll create an encrypted connection that is signed on both sides with a trust chain based in our service mesh. Now, spying containers can't see the traffic flowing between our services, even if they're inside the same cluster. The traffic is flowing over an HTTPS connection, but we didn't need to alter our code to use HTTPS. The sidecar proxy created that for us. That's really cool. We don't need to change our code, but now we've secured communication within our cluster. If you need to be able to visualize your cluster contents, or you need to be able to create access policies between them, or you need to secure communication between your services, a service mesh can definitely help with that. But what's really cool is we can level up from there. It's not just a proxy, but because we can observe all of the traffic flowing between things, we can do things like create a network topology map. Which services call what? Now this isn't what the developer thought was going to happen. This is what is actually happening. Now maybe we can compare this map to what the developer had in mind, and we can say, you're not actually calling the configuration service. Did you forget in hard-coded debug value? We can also take a look at service health. Now, as we're looking at these communications, we could say, this service is starting to throw 500 errors. I think maybe this service is unhealthy. Maybe we need to restart it. And we can log all the traffic. We can log the communication. We can log uptime of particular services and get a good sense of how our system behaves in a healthy state. Well, let's level up again. Not only do we have the ability to observe, secure, and control, now because we're proxying between all the things and we understand what healthy and unhealthy means, we can do interesting things like A/B testing. Let's send different versions to different clients and start to learn which systems behave better for our users or for our bottom line. We can also create a beta channel. Let's release the new features early to certain users so that those users can play with the features, validate that they work, get access to advanced copies of things. We can create these beta channels because we're proxying content on the way into our service. We could also create circuit breakers. Circuit breakers are elegant ways to say, hey, I noticed that this service is going down. I'm going to get in the way. Now, typically when we get network failures, we presume that they're transitory. Well, maybe there was just a network blip. Let me retry. If a service is starting to go down, if a service has failed, and then all of the dependent clients start retrying, as the service comes back up, it's gonna get buried. It'll get buried, it'll topple over again, and well, then it'll go down again. We can notice that. We can create a circuit breaker. As the circuit breaker opens, we can say, you know, this service needs a little bit of time to get healthy. So I'm just gonna bounce all the requests. I'm gonna fail them straight away, not even forward it off to that service. Once the service is resumed and healthy again, now I'll start sending traffic back to it. Now this circuit breaker isn't like, you know, I have to go to the fuse box and turn it back on. This circuit breaker can watch the traffic, watch the health of the service, and as the service becomes healthy, it turns itself back on. That's really cool. We've leveled up from observe, secure, and control to really elegant mechanisms where we can really shape the traffic within our cluster to do interesting things. As we start looking at service meshes, we'll likely also have dashboards that show us really interesting things. Now in this case, these dashboards aren't super interesting, but we've got a Grafana dashboard on the left, and we've got a service map on the right. Now this service map is what is actually called in our cluster, not what we believe is the topology map. This service calls into this service, and this service calls into we've got an exact map of how our service behaves. As we look at this mechanism, our goal is to prevent unexpected traffic patterns. Now remember when this microservice was able to call into the other microservice's data store? We can create an access policy that says, nope, a service owns its own data, and only that service can contact that data store. Service meshes are great for being able to control this out-of-bounds traffic. As we look at service meshes, we might say, well, which one should I choose? Istio, LinkerD, Open Service Mesh, Console? Now they're really good at keeping pace with each other, so if we're looking purely at features, yeah, they're all pretty much the same. Instead, let's look at methodologies. As we look at LinkerD, the goal of LinkerD is to be a really simple install, to get in, to do the bare minimum, and to get started really fast. By comparison, Istio wants to include as much open source software as we have. We can create profiles that turn things on and off, and we'll have lots of open source pieces to choose from. LinkerD is really good at being a really lightweight, really fast install, but they tend to build all the things themselves. They're a great contributor to the REST community, but if I want to step outside the bounds, I'll probably need to pull in some external plugins. With Istio, I'm probably more focused on turning things off that I don't need. Istio has profiles that allows me to turn on or off mutual TLS, some of the dashboards, some monitoring. And so whether you choose LinkerD, Istio, or any of the others, you'll have these same observe, control, and secure metaphors. Let's dig into a demo of both LinkerD and Istio. Here in this, here I have a Kubernetes cluster that is geared for LinkerD. I'm going to start off by looking to install LinkerD. Let's look to the docs here. And LinkerD's Getting Started guide is really cool. I grab the LinkerD install, or I grab the bin. Once I've got the bin installed, then I do a LinkerD check -- pre. Let's do it. LinkerD check -- pre. This will go validate my system and see if I'm ready to run LinkerD. Let's go check all the Kubernetes pieces, check to see that I've got my content ready to go. Yep, it's good. LinkerD install, I'll pipe that to kubectl apply -f, and now it's going to go start up my LinkerD service mesh. Now in this case, I'm running it on Minikube, but you could definitely run it anywhere. Here's that LinkerD install, pipe it to kubectl apply, and now we can do a LinkerD check to see if it's running. The cool thing about LinkerD check is it will actually wait for it if it isn't ready. Then I can do a kubectl-n in the LinkerD namespace and get all of the content that I've deployed. Let's take a look and see if it's ready. LinkerD check. Okay, so it looks like it's not quite ready. I've got some containers spinning up, and that is totally fine. LinkerD does take a little bit to spin up, but once we've got LinkerD spun up, then we'll have some really, really cool dashboards to get ready. Let's give it a second. LinkerD is coming up. My machine is doing a few other things, so it makes sense that this might take a minute. Okay, we've got the control plane ready to go. Very nice. Oh, I jumped the gun there, waiting for this check to complete. The way both LinkerD and Istio work is they create an annotation on each namespace. And that annotation says, should I inject the sidecar proxies? Once I've got that annotation on my namespace, anything created within that namespace will have the sidecar proxy and will get the benefit of our service mesh. In both LinkerD and in Istio, once we've got that in place, then we're ready to go. kubectl-n LinkerD get all. Here's all the content that we just created. Yep, there's quite a few. Let's take a look at the LinkerD dashboard. LinkerD dashboard. Now the LinkerD dashboard is great at being able to take a look at our cluster. If I come in here to the LinkerD namespace, I can see all the content in my cluster. There's some of the stuff. I've also got links off to Grafana dashboards. Now this cluster has obviously been up for a moment, so these dashboards will be decently empty, but instantly we have visualizations of the content within our cluster. That is really cool. If command line is more your thing, and you don't want to look at the Prometheus sinks, then you can look at LinkerD-n LinkerD stat. Now I'm specifically looking at the LinkerD stats in the LinkerD namespace, but I could just as easily do this in whatever namespace my application happened to be in. Oh look, my application is 100% up. That's perfect. My LinkerD service mesh is doing just fine. Well, let's set LinkerD aside and let's look at Istio. Now here's a separate Kubernetes cluster where I have Istio installed, and in a similar mechanism, I've already gone through the steps of getting it started. I download the Istio command line client, I start up the Istio thing, and once I've got it, I have this really cool sample application that can highlight the benefits of Service Mesh. I have a product page. It's going to reach out to the product details to get that content, but I also have a product reviews service. Now in version 1, it will show no stars. In version 2, it will show stars in black color, and in version 3, it'll show stars in red color, where it reaches out to the rating service. Here's my sample running inside of Istio, and right now, I've got it set to equally weigh to each of those 3 versions. So you'll see the stars come in black color, come in red color, and eventually, if we can find a request, they'll disappear completely. Nope, they're not gonna do that. Okay, let's look at this and let's apply the version that only goes to version 1. Here's the virtual service that I have, pointing it equally at the 3 services. Let's grab virtual service 1. I'm going to kubectl apply this. And now I've pushed all of the traffic to version 1. All of it is going to version 1 service. So here's that version 1 service. And in the version 1 service, I have no stars at all. As I'm getting going, I may choose to point, well, 20% of my traffic to version 2 and 80% to version 3, or version 1. So I want to test out my kubectl apply-f. I want to test out my new service, so I'll only send a portion of the traffic there. Let me hit refresh, and if we time it right, we might see some stars. Nope, in this case, I'm in the 80%. There we go. So version 2 is working correctly. Let's come back here and we will send all of the traffic to version 2, but I want to do some testing between version 2 and version 3. So in this case, I'm going to say, if the user's name is Jason, I'm going to let him view version 3. Otherwise, I'm going to send him to version 2. So right now, we're in the unauthenticated piece. We have version 2. I'm going to sign in as Jason and no password. Now I'm authenticated as Jason. And if I refresh this page, now I'm seeing version 3. Yeah, there we go. There's the stars in red color. I sign out, and I'm back to version 2. Once we get it going and we've got it good, let's push all of our traffic to version 3, and now everyone will be able to see the red colored stars. Now, the cool thing that we saw in this process was we got to do an A/B test. We got to do a canary release. We also got to see how, with no downtime, we were able to push the traffic between pieces. Now, here inside, that's LinkerD. Here inside Service Mesh, we also have some dashboards. Let's take a look at, Istio CTL. We have a Prometheus dashboard, but for the sake of time, I will jump over that one. Here's a Grafana dashboard of our Istio cluster. And so we can see here inside Istio, let's go find the Istio control plane, and we've got great insight to this cluster and the Istio service mesh. A similar dashboard, but also a very different dashboard. This one's really cool. Istio CTL dashboard Kiali. I've only seen this written, so I hope I'm pronouncing it correctly. This dashboard is particularly interesting because we can see the visualization of how our, I'm failing to fetch. Graph tab. No, that dashboard's gonna fail. Bummer. The interesting part about this Kiali dashboard, and it's unfortunate it's not pulling up, is it gives us a map of all of our services. And so we can see what actually connects to things. Istio CTL dashboard Jager. Let's see if the Jager dashboard is able to give us similar visualizations. Yeah, here we go. Dependencies, DAG. Now here is what's actually called within our system. The Istio Ingress Gateway calls the product page calls the details default, the reviews service will call the rating service. This is what's actually happening in our cluster. Our north-south traffic and also our east-west traffic. This is a really cool dashboard. Now what's cool is that each of these mechanisms inside this service mesh allow us to do the things of observe, secure, and control. At our most basic level, observe, secure, and control, we can take a look at our traffic, monitor, logging, service health. But then as we start our crawl, walk, run journey, we can start to take more control. Let's do intelligent routing. Let's do A/B tests. Let's do circuit breakers. Then let's level up again and start looking at a network topology diagram where we can see what services actually call other services. Now this isn't what the developer had in mind. This is what's actually happening in the cluster. It's really cool. Now service mesh isn't for free. In a regular Kubernetes cluster here on the left,
I'm afraid I'm going to have to jump in here.
I have my control plane, I have my pods, and in a service mesh, I still have a control plane and I have those proxies. So you're not going to get it for free.
I'm afraid I'm going to have to jump in. Sorry, we're running out of time. Do you want to jump to just to like kind of catch up slides so people can ask questions afterwards?
Most definitely.
Thanks.
Let's jump into questions.
I don't think we have time for questions, but if people got your Twitter handle or your website, we can follow up there.
Yes.
All right. Thank you very much.
At Rob_Rich. You can grab these slides online right now.
Thank you very much.
Thanks for coming, everybody. This was so much fun.
Thank you very much, Rob. That was great.